Jai Hind. The topic which we are going to discuss today is data management issues in mobile computing, and after that we are going to discuss data caching techniques. So data management issues in mobile computing, basically it is the part of your unit 3. So mobile computing, we are aware that it allows the users to access the database from anywhere and anytime from global information system, and we are aware to access this service we do require internet services. It adds new dimensions to distributed computing. So as far distributed computing is considered only for fixed networks, but since nowadays we are working on smartphones, or you could say tablets, and fast running laptops, then we are working on the applications, or we do need to access the database when we are in movement. So basically what this unit talk about, this lecture talk about, that is what are the data management issues we need to consider in the distributed environment pertaining to mobile computing. So these are the issues which we are going to discuss one by one. Location management, wireless medium, portability of mobile devices, caching, data replication, broadcasting, transaction management, quality of service. That is how we are going to address these issues and why they are posing as a challenge when we say that we need to manage the data in specifically in mobile computing environment. So location management, basically we are aware that when you are in movement, then handover is taking place side by side. Now this, in unit 1 we had discussed this handover, it can be within the same cell or it can be between the two cells depending upon the requirement. So the location of the mobile devices and their point of attachment to the fixed network, whether it is your base station or whether it is your access point, they are continuously changing. So due to this change, what are the challenges? That is the current position of mobile device. We need to address this issue, that currently in which cell the mobile device is operating, so that the data can be sent to the correct location. Store somewhere the location information. We need to store this information because the mobile is your device is in mobility, and for example if you are in a train, then you are frequently changing the cells. So we do need to store this location information somewhere, so that if you want to access some data which is related to location, which is based on location awareness, then in that case that particular your location, it help in extracting that information. Then the variation in connectivity during movement affects the performance and the reliability, that is dropout rates. Sometimes your internet connection is intermittent. So such kind of things need to be dealt with when you are using the database or you are doing some database activity. Number of devices in the network cell changes with time. So both the load at the base station and availability of bandwidth. Again, this is a challenge in front of the data management service providers. That is how, if for example you are in a cell and it is heavily loaded, or it is already facing the network congestion, then how you will get the seamless services. Next important challenge is the wireless medium, and all those issues which are related to the wireless network, same challenges, they also come here when we are working in the data. When we are working on the data, weak and irregular connectivity. So if you are using some data and your connectivity is irregular, then how you make sure that the data on which you are working is the correct or the consistent data on which you are working? It need to be find out, it need to be work out. Wireless communication face many obstacles because surrounding environment interacts with the signal, that is signal interference. This is a challenge. Low bandwidth. This is another important challenge because the total bandwidth, it need to be shared among the various users who are present in that particular cell, whether they are the home users or whether they are the visitors. Mobile devices frequently may disconnect. Sometimes you are having the charging issues with your mobile devices, or you could say device constraints. They are also present when we are working in the wireless medium. Bandwidth and the reliability of the wireless medium is variable. This is also important constraint. Then base station has a high bandwidth channel to broadcast to all clients in itself. Network access charge, that is per message, per connection, per unit time, all these things, they are posing as a challenge when we, that is how we work on these challenges when we are working on the data in the mobile environment. Another important issue is the portability of the mobile devices. Since the mobile devices, they need to be carried out throughout your movement, so they should be small, they should be lightweight to be easily carried around. But since they are becoming smaller and smaller, they are becoming more lightweight in nature, so it will affect the computation power on the device. Moreover, the screen size, it becomes limited, so sometimes it is very difficult to access the you could say your whole database. So such things need to be addressed. That is how we are going to work in such a small device if we are connected to a database server. Due to above consideration, mobile devices have less resources, which I already discussed, memory, screen size, etc. Concern for power consumption, there is also important thing. If you're working on a laptop, no doubt you can carry out heavy computation which require a good amount of power, but since in the mobile devices power consumption is a main constraint, so how we are going to compute the queries, this is an important issue. Mobile devices are easier to accidentally damage, lost, stolen. That's why they are less secure and less reliable. That is, if your device got damaged, then how you are going to access your database application. This is an important thing. Another important challenge is caching. As we are aware that in mobile computing, caching is a useful during frequent relocation and connection to different database servers. So we can store maximum amount of data in cache, but still what we have seen earlier, that the devices, they are small. Then again the question comes, how we are going to store maximum amount of data in a small cache. No doubt, if we are storing the maximum amount of data, it improves the query response time. So again, caching is an important property which we require here. Also, it supports the disconnected and weakly connected network. So caching is an important aspect, but then again the question comes, how we are going to store maximum amount of data or the frequent data which we are frequently using in a small cache. Moreover, if you are storing the data in a cache, then the next question come up, whether that cache data is in consistency with the database. What if the data in the present in the database got changed? So immediately it would be reflected to your cache. But suppose you are disconnected at that time, so you don't get the updation. So ultimately what is happening, you are working on the obsolete data which is present in the cache. Then how your how you can address it, such issue? This is an important question. Data replication, we are aware that in the distributed environment, data replication is an important part of a distributed environment. So the data replication, basically it is the data storage and backup strategy that keeps the copies from host system to another system. So data replication, it is very popular in DBMS, and it provides redundancy across multiple database servers. Data replication is important in the mobile computing to increase the availability and the performance of the mobile databases. So we need to find the conditions to replicate the data on mobile locations, and moreover, all these replicated data copies, they must satisfy the ACID property of your DBMS. Another important thing is broadcasting. So broadcasting, what it means? Delivery of data from a server to a large set of clients, and this particular service is known as push based service, where the data is pushing the your server is pushing the data to client side. Now this particular activity, it may be periodic or it may be aperiodic, and it depends upon what the client require. So in the periodic push, what is happening? Client may be disconnected for some period without missing the data but needs bandwidth again and again. Whereas in the case of the aperiodic push is more effective way of using the bandwidth available. In periodic push, what is happening? Periodically server is pushing the data to client side, but what happen if the client is disconnected? Then it won't get that copy. So what will happen? The client is working on the obsolete data. Whereas in the aperiodic push, what is happening? The client is sending the request, so it will never miss the report which is coming, which is being broadcasted from the server side. But again in this and this is more bandwidth efficient also. So broadcasting may use the multicast address, in which the server sends the data to a group of clients using the same address. Another important challenge is how we are going to manage the transaction, and we are aware that when we talk about the transaction, then the transaction, they must satisfy the ACID properties of your DBMS, that is atomicity, that is all or non actions, either all actions or the all transactions completed or none of them. Consistency, it says that the data, that whenever you perform certain actions on the database, then it must be left in the consistent state. And moreover, in the previous challenges, we have seen that we are working on the distributed environment. So consistency is an important factor, or you could say challenge here. Isolation, what it says, a transaction must not read intermediate result made by other transaction. And durability, that is, once the commit operation has been occurred, it should be reflected through all the distributed copies of that particular data. Mobile transactions may split computations into a set of operations, and some of which may be executed on a mobile host, while others, they might be executing on the stationary host. So it is an important challenge that some computation is on mobile host, whereas some on the stationary host. So how we are going to collaborate the final result? As mobile hosts move from one cell to another, so the state of transaction and the location information also moves. So we should have certain mechanism to address this challenge, that is how we are going to store the location or the state of the transaction when the node is in the mobility on which we are doing some kind of computation. Quality of service, this is another important factor, and in the mobile network, it is affected due to the network connectivity, bandwidth availability, it control the data transfer rates, connection reliability, data loss risk, etc. So we should have certain mechanisms or rules and regulations which will ensure that the quality of the service, that is the data delivery, it should be reliable, it should be available all the time. Now the next important topic which we are going to discuss in this particular lecture is data caching, which we have already seen that what is the meaning of the data caching, and it is an important challenge which need to be addressed when we talk about the data management in mobile environment. So what is a cache? It is a record at the client device, may be invalidated. So we need certain mechanisms to find out when we are using the data in a cache record, that whether it is a valid data or whether it is a invalidated one. This may be due to expiry or modification of the record at the database server. So what is cache invalidation? It is a process by which a cache data item or record becomes invalid and unusable. And why it becomes invalid? It might be due to modification, expiry, or invalidated, or itself invalidated at the computing system or server. So we need the mechanisms to find out that when the cache has become invalidated. Cache mechanisms, they are used to synchronize the data at other processors whenever the cache data is written or modified by a processor in a multiprocessor system. Cache invalidation mechanisms are also active in the case of the mobile devices having the distributed copies from the server. So, cache consists of several records. Each record is called a cache line, copies of which can be stored at other devices or the servers. That is, whatever you are working upon, your cache line, maybe other devices are also working on that particular cache line. Your servers, they might also be working on those cache lines. The cache at the mobile devices or the server databases at any given time can be assigned one of the 4 possible tags indicating its state. This is how we are going to check the cache invalidation, or these are the states on which the cache invalidation mechanisms have been built upon. The very first one is the modified state. That is, when we write something, we change it, we change the state of the cache line as modified. It may be exclusive, shared, or it may be invalidated. After expiry or when new data becomes available at any given instance, these 4 states, they are being pronounced as messy. That is, modified, exclusive, shared, invalidated. The cache states indicated by the various tags. So, E stands for exclusive, which means that the data record is for internal use and cannot be used by any device or servers. Why we require this particular state? Because in a cache, you are working on some data which is present on other devices, as well as in the same cache, you are working on the data which is exclusive, meant only for you. So you don't want to share that exclusive data with someone else, and also you need to keep a check. That is, whenever you are sharing a cache line with the outside world, then it is not the exclusive data. So how we are maintaining that difference? It is with the help of E tag. The S tag indicates the shared state, which indicates that the data record can be used by others. M tag, that is modified, which means that the device cache has been changed. The I tag indicates the invalidated state, which means that the server database no longer has a copy of the record which was shared and used for computation earlier. So you need to delete that particular cache line, and you don't need to work on that particular cache line, because now after invalidation it becomes obsolete for you. So if you look at this figure, the 4 possible states, that is messy, these 4 possible states, they are being maintained at both ends. Here we are having the mobile device and here we are having the server. So these are the messy state for the mobile device and these are the messy states for the server side. And this, in this client server architecture, it might be 2-tier, it might be 3-tier. So what's the EMI stands? EMI, it stands as exclusive at the device, that is your own mobile phone, and server cannot modify it. Similarly, SMI, it says shared with server or other devices. MMI, modified at the device after new record from the server. That is, you have cached something from the server and now you have done its modification at your end. That is why we have used the subscript MI. Then IMI, invalidated after the invalidation report from the server has been received. So you need to change its state to IMI. Now, what is the meaning of messy here? ESI, that is, we are using the subscript SI here. Exclusive at the server and device record does not affect it. That is completely to be used by server only, and the server is not sharing this particular data with any other device. SSI, shared with other devices or some servers. ISI, invalidated at the server and the report is sent to the devices. It is very important part in when we talk about the invalidation of the data at the server side. MSI, that the data being modified by the server. So the 4 possible invalidation mechanisms in this case. Another important factor for the cache maintenance in a mobile environment is cache consistency, which is also called cache coherence. This requires a mechanism to ensure that a database record is identical at the server as well as at the device cache, and that only the valid cache records, they should be used by all the users. We are having 4 mechanisms, invalidation mechanisms: stateless asynchronous, stateless synchronous, stateful asynchronous, and stateful synchronous. Now, what's the stateless asynchronous says? It says device cache states, they are not maintained at the server. Okay, they are being maintained at the mobile device only. Now, the server broadcasts whenever the data at the server end becomes invalidated, then it is broadcasting the invalidation report. Once the mobile device, it receives the invalidation report, then the client requests for the cache of the new data record if it is using it. Otherwise, it will ignore the invalidation report. So, what are the advantages? No frequent unnecessary transfer of the data reports. Mechanism more bandwidth efficient in this case. But what is the loss here? Every client device get an invalidation report whether that client requires that copy or not. So, bandwidth problem is there if we talk about this particular disadvantage. Moreover, client devices, they presume that as long as there is no invalidation report, the copy is valid for use in computation. Now, see the scenario, the server has sent the invalidation report, but the client is disconnected, then at that time the client won't receive the invalidation report, and due to this, the client is still working on the old copy. Now, the next important mechanism is stateless synchronous. It is stateless, so no state is being maintained at the server, but it is synchronous in nature. So, what it says, the server periodically advertises invalidation report. Now, if the mobile device does not receive the report till the end of the period, then the client may send the request for the report. So, the client never misses the invalidation report in this case. So, what are the advantages and the disadvantages of this approach? Client device receive the periodic information regarding invalidity of the data caches. The periodic invalidation reports lead to greater reliability of the cache data, as updated requests for invalid data can be sent to the server by the device client. This also helps the server and device maintain cache consistency through periodic exchanges. But what's the problem? Unnecessary transfer of data invalidation report take place because the invalidation report need to be sent periodically. And what happen if there is no updation takes place, but still the server need to send the report? Every client device gets an advertised invalidation report periodically, irrespective whether they has a copy of the invalidated data or not. Another important approach is stateful asynchronous. So, what's the stateful means? It says that the device cache state, they are now being maintained at the server side. The server transmits invalidation report to concerned devices. It is asynchronous in nature. The client requests for new data on receiving the invalidation report and send its new state after caching new record from the server. Why we require this thing here? Because of this concept, that is stateful. Now, the device cache states, they need to be maintained at the server side. So, what are the pros and cons here? Server keeps track of the state of the cache data at the client device. This enables the server to synchronize with the state of records at the device cache and keep the home location locating cache, that is HLC, updated. The stateful asynchronous mode is also advantageous in that it only affects the client receive the invalidation report who require this, and other devices are not flooded with the irrelevant reports. So this is a very important advantage of this particular scheme. But what's the cons here? Client devices presume that as long as there is no invalidation report, the copy is valid. Why? Because it is using the asynchronous mode. Therefore, whenever there is a link failure, the device will miss the copy and still it is working on the obsolete data. Another important and the last approach is the stateful synchronous. Device cache states maintained at the server because it is a stateful in nature. Now it is also synchronous. So due to this synchronous property, what is happening? The server periodically transmits invalidation report to the concerned device. The client requests for new data on receiving the invalidation report and sends its new state after caching the new data. If no report is received till the end of the period, then the client requests for the report. So what are the pros and cons here? The server periodically updates the client's cache states stored in the HLC, enabling to synchronize with the client device when invalid data gets modified and becomes valid. Each client be periodically updated of any modifications. When the invalidation report is not received after the designated period, due to some link failure, the device does not use the invalidated data. But what's the disadvantage? High bandwidth requirement to enable the periodic transmission of invalidation reports to each device and updating the requests from each client device. So this is the disadvantage here. So here these are the 4 step of a stateful asynchronous cache invalidation mechanism for cache consistency, which we have shown with the help of a figure. Here what we are having the database cache. In the very first step on data record invalidation, the state M or I for the device is being set here. So the device requests the data record, server sends the modified data, and the state change information is set for the HLC. This is how the things being done in a case of stateful asynchronous cache invalidation mechanism. So in this lecture we discuss about the data management issues and also discuss the cache invalidation mechanisms, which are very important when we are talking about the data management in mobile environment. So this is all about for today. Thank you and Jai Hind.